And welcome to part 6 of the chucK Granulator tutorial. In this one, we're going to look at automation curves. So we're going to use modify our parameters like gap duration or grain duration, any of these, using LFOs, low frequency oscillators, or some kind of ramp curves that we can build in. All right. So we're going to actually build a new function. And let's just go over it. Let's do a little review since we're at this point. So we have our global variables here, and that's just anywhere on the root level of our patch. And here, if you recall, we're just actually creating arrays of strings, and we're loading the paths to our samples and our envelopes here into these, just the string paths into these, so we can call them here. Now here's where in our main loop here, our infinite loop, that's refreshing every 15 milliseconds, we have an additional for loop in here that's going to call our individual grains. And the reason we have it in a for loop is we can have multiple grains play simultaneously. All right. So here we go. Is what we have is we have we're choosing our samples and envelopes, reposition, grain duration, etc., etc., etc. It goes on. Here we have a fixed one, but you can randomize these. And in our previous tutorial, we saw how we can kind of create a random range to which every grain can be slightly different in all these different parameters. Okay. So in this case, and then finally we have our function, which is the function that will generate one single grain. All right. And this just moves time forward on the root level. So let's start creating some ramps. We'll create a low frequency oscillator. We'll just do a sine wave oscillator. And that's just going to be a movement like an automation curve. Like it's going to move any one of these parameters over time. All right. So we'll create a new float here. And we'll just make it float, and we'll call it LFO1. Okay. And then we're going to create a new function for our sine wave oscillator. So if you recall, fun, and then void, because we're not returning anything, we'll call it LFO sine. All right. And then right now we don't know what arguments we're going to put in just yet, but they'll go there soon. All right. Now, we're going to have one thing we're going to learn about is this thing called black hole, which you can read about in the chucK docs. But basically, here you're sending it to the DAC, right? In our grain, we're sending these things to the DAC so the sound comes out. Black hole just allows us to do calculations on the sample level, but then not send it out the DAC. Okay, so we're going to create a sine wave oscillator. We're going to create a little patch, call it LFO, and we're going to send it to the black hole. Okay. And then we're going to calculate a frequency for the LFO. And what we want to do is we want to think about it in terms of duration. And I'm going to think about it in durations per second. So that's just the inverse. So if you go 1.0 divided by, we'll call the variable duration in seconds, dursec. Okay. And then we'll chuck that over to the LFO frequency. So LFO being a UGen, a sine wave oscillator, and then we can set its frequency using this calculation. Okay, and that's going to be this argument in here, and that's going to be a float, I think, yeah, dursec. Okay, so then for every LFO, we're going to say how long it lasts for one oscillation, right? And that's the full sine wave. That's up and then down and then back. And then it's going to go to the black hole so it doesn't make sound, and that's going to set its frequency. All right. Now within this function, we're going to set up a infinite loop. And then what we're going to do is, so in theory, or not in theory, but I mean, if we examine what's happening here, the LFO, the sine wave, is going from -1 to 1. Okay, we want to normalize it because that's more useful to us in changing things. So from 0 to 1, then you can multiply and you can do things like that very easily. All right. So we're going to use this function. All the UGens have these series of functions here, and I think we looked at these before. I just had it. Yeah, here. Okay. So all UGens have these control parameters, these functions. You can set the gain, and you can use this one called last, which is the one we're going to use. To get the last sample computed. Okay, so that's just going to spit out a sample, and it's going to be a float. Okay, so it's going to be the, I guess, really the amplitude there, the last one you did. All right, so let's go ahead and get last, LFO.last. Okay, now LFO.last will render a number between -1 and 1. That's what the typical sine wave oscillator does. It's a bipolar signal, right? So it goes from -1 to 1. So we just have to do a few little calculations. What we're going to do is we're going to multiply it by 0.5. And then now it'll go from -0.5 to 0.5, right? And then we're going to add back 0.5. Now, that way it's going from 0 to 1, all right? And then we're going to chuck that whole thing over to a variable, which we'll create. Okay, which did we already create it? We did, float LFO1. So we'll chuck that to LFO1. So that's going to do that calculation. It's going to find out what the last thing, the last sample is. So basically just telling us what the value of that is, the current value of that is. It's going to normalize it, and then it's going to set this global variable LFO1 to that number. So it's continuously oscillating. You can just read it from here, right? And then we just have to set a frame rate. We'll just do 1 millisecond to now. Okay. Alrighty, so that'll do it for this sine wave oscillation. Now we just have to use this LFO1. So what we do is we, on the root, not inside our grain, because this is dealing with each individual grain, but outside here somewhere, we're going to spork it. So we're going to spork, create an independent shred or independent, stream that's running this LFO sine. And remember, our argument then is just the duration. Let's make it duration of, like, say, 10 seconds. That means 5 up and 5 seconds down. Okay. Okay, it's going to go from 0 to 1 in 5 seconds, and then 1 back to 0 in 5 seconds, right? Just like a sine wave you'd expect, or the other way around. 1 to 0 and then 0 to 1. I'm not sure which one it starts with. Okay, and so then now you can apply that, this variable, which is being set by this LFO, you can attach that variable to anything. So let's try just having a simple gain one. Okay, so it's going from 0 to 1 and back to 0 again. So you don't really need to do much. You're just going to do LFO1, and you're going to chuck that to G gain, float G gain. Okay, and then of course that will be picked up here in G gain into our grain, or our grain here, right? And set the gain of the gain of the grain. All right, make sure we comment that out. And if we go ahead and play, okay, 5 seconds up, 5 seconds down. Let's make something much shorter, say 0.3, and have some kind of like a tremolo effect. Okay, maybe that's too frequent. Can't really hear the difference. Okay, and maybe even something like 0.5, a little faster. Oh, that's 5. Sorry, 5. I had to say 0.5. Where am I 0 here? Something like that. Okay. Anyways, you can play with that, so you see how that works. And you can attach it to anything you want here. Instead of the gain, we can attach it to playback speed. We can oscillate that. So we can then do something a little bit more complex. Let's say we want to go from half speed, 0.5, to let's say 3 times speed, something like that, 0.5 and 3, right? So you have a number going from 0 to 1. So basically, we want it to have a difference of 2.5. So 2.5 times LFO1, right? So that's going to oscillate between 0 and 2.5. And then we'll just add back 0.5. And then chuck this thing to float G rate. Okay, so that's going to oscillate between 0.5 and 3, right? This is going to go from 0 to, because this goes from 0 to 1, this is going to go 0 to 2.5, and then we're going to add 0.5. So it's going to go from 0.5 to 3, right? Our rate's a little quick. But we can have like a vibrato. Let's see what that sounds like that. 0.3. Oh, 0.4 is fine. See what 0.1 sounds like. Okay. So anyways, you get the idea, the basic idea. Okay. So let's abstract this a little bit so that we can have something that works a little bit better. Oh, no. The final thing I wanted to show you then is just to abstract it into this randomization. So you can have the LFO work on both sides of the random equation, right? So you can get something that moves, but it still has some kind of randomized space, right? So you need a min and a max for that and a min and a max for that. So for example, if I wanted to change my grading duration from a minimum, say, so it's like having two of these math randoms, right? It's kind of like having two of them. So on the minimum end, you'll have something that goes from, say, like 5 to grading duration 5 to say whatever, like 30. Okay, that'll be the on the minimum side, and then on the maximum side, you'll have something that say goes from like 50 to, to like 150 or something like that. Okay, so in fact, it's more like this. It's like between 5 and 30, and then comma, 50, 150. Something like that, right? Okay. So let's work that out. So now we have a bunch of variables we're going to work out. I'll show you how it looks here, and then you could work it out. You're going to have a min and a max, a min and a min max, and then a max min and a max max, right? And then you're going to take a difference, your difference, so the max minus the min, both sides, and then you're going to calculate this by having the difference times the LFO. So this is going to go from, just like we did over here, the difference between the two, 2.5 times the number between 0 and 1, and then we're going to add back in the GDR max. Okay, so I do it slightly different this way. Right. Either add from the min or subtract from the max. In the example I give you on GitHub, I subtract from the max, but in this example, we'll add from the min, just like I do here. Okay, if that makes sense to you. So let's just copy all this here, and you can kind of go over it on your own speed. Just pause and have a look at it if you want. So if we wanted to do something like this, we're going to have a G-gap min. Okay, that's this, say 5. And a G-gap min max, that's 150. We'll say 30. And then a G-gap max min, that's our 50 here. And a G-gap max max, which is 150 there. Okay. And then we're going to take the difference between these, the difference, G-gap min difference, G-gap max difference, and then we'll take, in this case, we take that max and we subtract the difference times, we'll say LFO1 there. But you can add from the min too if you want. You can do min. and you can add that. Okay, and then we're going to calculate our green gap right there. All right, so let's get rid of this, and we have all this, and that's going to work out. So our green gap. So our green gap is going to start somewhere between 5 and 50, and then it's going to oscillate up to somewhere between 30 and 150. Let's give it a go. Okay, and then maybe we'll tweak something a little bit, like maybe make the min go longer, maybe like to 80, something like that, and that'll be the min max. Maybe that's like 300. So maybe make it a little bit more dramatic, and that's like 15. Okay, 300 here, and then we'll do it over, say, 8 seconds, something like that. There you go. So you see it oscillates between 5 and 15, or 5 and 15, and then 80 and 8. So this one was like 5 and 15, and then it goes to something that goes from like 80 to 300, right? 80 to 300, 5 and 15. All right. So hopefully you can make out how we got that. Just a little bit of math there. Okay. So the final part of this is now to make one that is a fixed ramp that'll only ramp once and then stop. Okay, so let's do a ramp generator here, and we're going to do something very similar. So we'll just copy that function. It's similar enough, and we'll just add a couple things. Okay, first of all, let's do a phasor. So we're just going to go from 0 to 1. Okay, so you won't have to do any of this calculation now, because that's going from 0 to 1. We'll send it to the black hole. We'll call it ramp. And we'll call this one ramp. I guess we're calling this R. Okay, send that to the black hole. R freak, same thing, same kind of calculation, deer seconds, the inverse there. Now, one thing, so it's a limited time ramp, so it's just going to last for this and then stop, okay? And so we're going to do a little calculation. We're going to do from now, and we're going to add the deer seconds as seconds, right? Okay, I'm going to chuck that to time. We're going to use a time data type, all right? It's going to be time, and we'll call that time later, because these all calculate in time, the data type of time or duration. And I'm not sure if those are different. You have to look that up. And so then now, the while loop, instead of being infinite, we're just going to go while now is less than later. So it's only this loop will only last as long as this deer seconds, right? Because we're calculating the time from when we start this function to adding that deer seconds, and it becomes later. So while now is less than later, we'll go R last, and that's going to be the last sample, and it's already going from 0 to 1, so we don't have to normalize it here. And we'll have one, we'll call it R1. We'll just call it ramp 1, something like that. We have to create that variable up here, ramp 1. Float ramp 1. Okay. And then I think the only other thing we have to do is just now we'll move this ahead in time by dur seconds. So dur a second. And we'll move that up to now. Okay. And so now we have our fixed duration ramp. It'll only go from 0 to 1 over this and then stop, while now is later. Okay. So let's apply it to something. We have, and it's changing the variable ramp 1. So let's make well, we can just make the playback speed again. Let's try that. We can make kind of a long glissando. So we'll just take it and we'll go from, we'll do something very similar to here. So we'll just copy that. And let's go from 0.3, okay, to say 5. So we do 4.7, right? And we spork it up here, just like the other one, or spork. And I think we called it ramp. And we'll make that ramp last, say, whatever, 5, something like that, okay? And then if we play... And so you notice it doesn't come back down in pitch. It just stays up there in pitch. Okay, try that again. But the sine wave is still going. Okay, and you can do, you can do different directions too if you want. You can go from, you can do minus, right? So you can go from 5 and minus 4.7 times ramp 1, so it'll go to 0.3. So let's try what that sounds. Okay, so then that's how to use the ramp. All right, so basically we created 2. Now, if you wanted to create several different kinds, you can. You just can also use a different U-gen. There's like the triangle one, which just goes up and down. There's a sawtooth, which is essentially the same as the phasor, and various other ones too, sine wave oscillators. You can also create your own custom ones. They have custom wave tables. So you can use all those as these low-frequency oscillators. And you can use anything in here too, and it'll just be a one-time thing. So for like sine wave oscillator, you can have it go so many cycles, or for so many durations, and they just stop, that kind of thing. So this is more about having a fixed time rate. Okay, so hopefully that was helpful. Thanks for watching.